Ladies and gentlemen, please welcome back to the stage your MC for the day, Jason Stein.
Right. Welcome back from the break. Thank you. Well, if it's 2020, as I mentioned before, then it must be flying cars time, right? I mean, we all expected this was going to be the decade where this is going to happen. Well, it's predicted by 2050, which, let's face it, it's just around the corner, 70% of the world's population is expected to live in urban areas. And that means urban air mobility will be at the center point of every conversation and will have a significant impact by that time. The following panel includes experts in the urban air mobility ecosystem, from operators to regulatory, local government, real estate development, aerospace developers, and research organizations. What remains to be done to further enable autonomous urban air mobility? How will technology mature, evolve, be adopted? Let's get this conversation started. And leading it is Robin Lindenberger, Deloitte's U.S. and global aerospace and defense leader. Robin, the floor is yours.
Thank you very much, and welcome everyone. I appreciate everyone coming out today. We have a very strong panel to talk about the issues that were just raised. Let me give a quick introduction on everyone. You'll see, you'll be able to track them up here on the slide. So with us today is Wyatt Smith. He's the head of business development with Uber Elevate. Mr. Scott Drennan, who is the vice president of Bell's innovation team. He has a long career focused on VTOL development in varying configurations, including the V-22 and most recently the Bell Nexus. Hassan, you said just the first name was fine.
Perfect. Perfect.
It's Ikrata. I stumbled there a bit. Serves as the executive director of Southern California's Association of Governments, the largest metropolitan planning organization in the United States. Parmel Kapatkar serves as the director of NASA's Aeronautics and Research Institute, and in this role he's responsible for exploring the trends and related needs, future needs specifically, related to aviation in the areas of autonomy, aeronautics manufacturing, and advanced air mobility. Thank you, PK. By the way, the film that we ran on during the walk-up is a production of something that Parmel and team have done. Russell Laughlin is the executive vice president of Hillwood, where he oversees the management, operations, land and infrastructure planning for Alliance, Texas. For those who don't know Alliance, Texas, it's a 26,000-acre mixed-use and master-planned community, which includes the Alliance Airport just north of Fort Worth, Texas. I think the mayor of Fort Worth was on a previous panel here just a little bit before. Hopefully they didn't steal our thunder here. And Ms. Jody McCarthy, who's the Deputy Assistant Administrator of the Office of International and Environmental Affairs, where she's the Vice President of Management Services. This ensures the improvements and advancements necessary to take on the air traffic of tomorrow are being addressed. So great. I think I've got through that. So what we formulated the panel as we talked a little earlier about one group that really sort of represents the needs of those that are the future customers. After all, this is the Consumer Electronics Show. It's about the customers and consumers. So we wanted to make sure we represented those needs. Nextly, those that are going to be in the operations and or manufacturing of the future vehicles, talk about how that's coming along. And then obviously the policymakers and regulators with NASA and FAA here talk about the kinds of things they're doing to move this market forward in a responsible way. And as it is CES, as I mentioned, I just wanted to give some highlights on a report on the second annual survey that Deloitte conducted globally of potential users of UAM, urban air mobility, in a flying taxi. This is our second in a series. Just give you a couple of highlights. About half of those surveyed agreed that the passenger UAM vehicles concepts are viable for urban, suburban, and rural mobility. So half the populations think we're headed in the right direction. The other half, 1/4 is not decided and the other disagree, but I think we'll always have those that sort of disagree. While the survey results don't change year over year across generations, what we're seeing is the younger, Gen X, Gen Y, if you will, in US terms, are those that are actually more favorable and have more confidence in the future, which is probably good because by the time we get to scaled operations, they'll be the ones that we're targeting as customers iterate rather than someone of my age, say the boomers, who are a little less agreeable to this as being a viable method. And what was interesting this time around too is we're seeing that suburban and rural respondents are more agreeable to this than are the urban. So it'll be interesting to see from the user's perspectives does that change over time. And so with that, I thought I'd start out keeping on the theme of talking about potential customers. I'm going to address this to Hassan and Russell. And Hassan, if you wouldn't mind going first. From your points of view, how does this modality, this new method, potentially serve your constituents' needs, whether those be the citizens or those you're developing the land for? What's the value to be created? And how do you consider those? How should we consider those needs as we move forward?
Thank you very much for having us, and good morning. I think we're still in the morning. Good morning to all of you. You know, I think if I knew what future mobility would look like, I would be a rich man today. But we all need to anticipate the future when it comes to transportation. I lead 400 brilliant people at San Diego Association of Governments. We plan for the County of San Diego, 3.3 million people. And we're actually about to start talking about what would the future transportation system look like. You all hear autonomous vehicles are coming. How many of you think we're going to have 10% of the fleet next year autonomous? About 1%. How about in 50 years? And that's the question. What would a future transportation system look like in urban regions? How do we sustain ourselves with building a transportation system that's transformative, but yet anticipate future technologies? Obviously, from an urban transportation standpoint, we don't want every one of us to be running in their own Uber and Lyft, because we don't have the infrastructure capacity to handle that. But we want to be able to say we're designing a transportation system that's actually going to sustain the region, at the same time provide options, choices for people. Right now, most of our urban regions have one choice, and that's the car. We're running out of space to build infrastructure for that. So we are developing, as we speak in San Diego, something we call the 5 big moves. A system that provide a fixed guideway system, but also look at flexible fleets, look at mobility and technology. And we're really honored to partner with Deloitte in looking at that future mobility solution. I can tell you, regardless of where you are from our great nation here or the world, if you want to know what a good urban transportation system will look like, come to San Diego. Come to Sandag. We are gonna, in a few months, we are actually gonna put forth a system that we believe is transformational. It relies on systems that we know, anticipate future systems, but also flexible enough to adjust themselves. San Diego is no stranger to innovation. We're actually the first in the country to try autonomous vehicle on the I-15. We're one of the few in the country that has movable dividers in what we call a complete corridor on I-15. We are designated as one of 10 in the region to try the drones and delivering goods that way. And we still have the most beautiful beaches in the country. And so somehow we need to get these two worlds to collide, provide transportation. Future mobility is all about accessibility. Future mobility is all about getting us to move in a sustainable way and economically viable way. So that's what I think the future would look like for us.
Thank you, Hassan. Russell.
Very good.
Land
Hassan, I can't follow up with beaches from Fort Worth and North Texas, but I'll certainly try. Okay, so Robin, a very nice introduction on Alliance, Texas. So let me set, as I answer the question of our constituents, who's going to use the world of automation, whether it's ground or air? Our customers, our clients, our partners. So Alliance, Texas, 26,000 acres, over 250 Fortune 500 companies, 45 million square feet. Inside that 45 million square feet is led by e-commerce companies, Walmart.com and Amazon. So now we're starting to push the envelope on quick delivery, which takes us into the aerial piece of it. So across this platform, almost 250 miles of roadways, logistics, good movements out of an intermodal port, inland port, 1 million lifts a year, efficiency of moving goods through a population of 10 million people. And if you take it up 500 miles, let's call it 20 million people, Austin up to Kansas City, Oklahoma City. So our constituency as a real estate developer are ultimately our consumers who are receiving products, and we're all responsible for the import of goods. Each of you has one container a year that you're responsible for bringing into this country. So how do we get it to the retailers, to your doorsteps? So that takes us into the world of ground and aerial. And what that looks like in the future to us is certainly that the automation, you heard a little bit from this on the panel prior, the automation through the efficiency of goods movements on the surface. Perhaps the most intriguing to us is the automation and the goods movement in that unmanned aircraft space, and that is quick delivery of high volume goods. Certainly our e-commerce partners are leaning into this heavily to try to figure out how to go from airport to intermodal, airport to DC, DC to your customer delivery door, wherever that is in your home. So as we look at this, our constituent moves all the way through the food chain of our logistics providers, our e-commerce distributed providers, and our customers. And that's based off the real estate platform of Alliance, Texas.
Thank you, Russell. Wyatt, so and Scott, we kind of moved through this. So now we've got the group that, the builders, the innovators of the actual platforms we're going to be using, and those that are looking at being an intermediary or an operator or a provider of that service. So I'm interested, Wyatt, how do you think about this push towards autonomous operations? Talked about the term accessibility, Hassan talked about. How do we make that accessible? What do you see you're thinking, and perhaps some of the challenges you're seeing?
Yeah, certainly. To start with, thank you for inviting us to be part of the panel. It's really exciting to be here. At Uber, we've been thinking about autonomy for some time. Obviously, our investment in a self-driving program on the ground has been a flagship one for us as a company. We believe it's important to the future of mobility. It's important to future mobility in the air as well, but we think that the responsible way to think about bringing this technology to life is with a piloted service, and we're very focused on working with partners in that sense. Our long-term view is to be able to lower cost for customers. And you do that by thinking about ways to drive more system efficiencies. And there are lots of opportunities for doing that. I think the key for us is to work really closely with world-class manufacturing leaders. We're very fortunate to have a partnership with Bell, and excited to have Scott share about that. I think in the context of those partnerships, we find the way in which we would think about market entry, which is largely related on doing things in the right way with a big focus on safety. Safety is at the center of our business and how we think about delivering a reliable service for humanity. And it's one that we believe requires an ecosystem and requires the hard work of lots of folks from around many different parts of that ecosystem to be successful.
Great. Scott, you guys are well along in the development and beyond the conceptual development of a vehicle. How do you think about this and again, this idea of accessibility?
Yeah, I think autonomy is really exciting in the air. I think we can win if we want to answer the question of ground versus aerial, but not say it in a way that makes either of the two sound too easy. Wyatt mentioned that it's the safest, best path to start with a pilot on board the air taxi vehicles, and I agree with that. But in order to unlock the true economical potential of the system, we need to get to that more autonomous state. And I think we can. I think there's structure in the air that allows us to do it more cleanly when you're talking about manned machines and unmanned machines interacting together. I think there's more space up there. It's a little more easy in terms of decision making, I think, than some of the ground scenarios that I've read about and that we've all seen happen in different cities. So I'm really optimistic about autonomy. I love this panel because it's got all the right pieces to make autonomy work. That's the other thing that we need to always think about. Autonomy doesn't just come from the Nexus vehicle. It comes from the digital infrastructure, that an Uber would work on, that we're working on as well. It comes from physical infrastructure that Russell's talking about, and it involves communities like San Diego, government agencies like the FAA and NASA, and autonomy. Yes, it's only one piece, but it's really critical to have all of us talk about it and figure it out together to make it work in a safe manner.
Right, well, that's a great segue. A question here for Judy. So clearly, FAA is focused on safety all day, every day, right? You mentioned it's a key component, and some of the feedback we get in the surveys that we do, it's about safety, right? People will think it's an attractive solution when they feel it can be safe. So how is the FAA working with industry to address the challenges of this rapid innovation and development of autonomous systems? Our technology moves much faster sometimes than we can think about how to roll it out responsibly, both in the unmanned aircraft systems as well as their safe integration into the national air system.
Right. So thank you. Yeah, and safety is our favorite word in the FAA. So I'm thrilled to hear it mentioned repeatedly up here. We are proud in the FAA to run the busiest and the most complex airspace in the world. So, and even across the world, wherever American passengers or aircraft are flying, safety is our primary mission. And the way to get down this road with all of the different entities that we have here on this panel is early communication and collaboration. And I think there's plenty of instances where we're doing that with a long way still to go. We have already held a couple roundtables with the UAM community. I think there's been 2 so far, and I think we've got a 3rd one scheduled this year, so we'll continue those discussions in any way possible. We've had conversations on UAM for years. The early ones just kind of describing what we see our challenges are and what are our obstacles and what are the opportunities. Over the past couple years, we're really honed in on finding an integrated approach to UAM and working our way through this. So.
Awesome. Thank you. PK, a similar question. NASA has a role in the development, as your organization does, in trying to help us accelerate the innovation and the technology. Can you talk about what NASA is doing in this area?
Yeah, sure. Thank you for having NASA on this panel. We appreciate that. One of the things that NASA really cares about is aeronautics, the first A in NASA, where we are really after the future of aviation. And when we started to think about urban air mobility and advanced air mobility, we first conducted market studies to understand the need and how long will it take to build that market, what kind of barriers we need to consider and address them through research. So primary focus that we have inside NASA is to do the research, conduct the research, set up the requirements, and break the barriers so that we can enable this new market that we are so excited about. And as we started to do that, we categorized them into aircraft, airspace, and infrastructure. One of the things that we are focused on is building this cascading progressive ecosystem, what we characterize as urban air mobility maturity levels. So those go from 1 to 6. And the idea of urban air mobility maturity levels is to start progressively with low density, low complexity airspace and low density operations, and then slowly increase to the high density and such. So as part of that continuum, as you heard, is you start off with the piloted operations, but slowly increase the automation autonomy on the cockpit as well as infrastructure as well as aerospace systems to enable the high density and high complexity type operations without overloading the current air traffic management system and enable that scalability with a safe manner. So we have been working on airspace technologies. We have been working on aircraft technologies, understanding the requirements that it takes for aircraft to operate in an urban airspace, as well as the aerospace system that enables the scalability and the infrastructure where you can take off and on without basically having to overload the rest of the system. Towards that, we started to put 3 basically prong approach. First is to conduct a grand challenge to study how ready the ecosystem is. That includes the aircraft, airspace, and infrastructure. So the grand challenge will allow us to understand how far progress we are making, sort of a dashboard or the progress indicator along the way in the ecosystem. So we are setting up the Grand Challenge. We have a number of participants already signed up, and if you haven't signed up already to support services for airspace or to bring aircraft, by all means, you can see me after the panel and be part of the Grand Challenge testing. We're also conducting research towards urban air mobility maturity level 4, that is medium density, medium scalability type operation with a lot more autonomy on aircraft as well as ground to see what would that set of requirements may look like. One of the outcomes of our research is going to be something we call Book of Requirements. So the idea is to develop the Book of Requirements that will satisfy the FAA's safety considerations, at the same time give developers and the infrastructure folks some things that they can refer to and build systems with that, so that the requirements will meet the ecosystem's need for scalability and density and safety. So that's the second part we are doing on the Book of Requirements. The third piece that we are doing is working groups. We clearly have learned many lessons along the last 5-10 years in terms of scaling these operations and taking advantage of the innovation that happens at forums like this and industry. So we are going to do working groups. We're going to have a number of working groups that focus on aircraft airspace as well as infrastructure. So the working groups will collaboratively work with us and what we characterize as collaborative innovation towards building that ecosystem and accelerating basically the transformation towards that while meeting the needs and requirements that are necessary to ensure the safe operations. So I'll summarize again. We are taking a three-pronged approach. The first prong is basically this Grand Challenge, showing and demonstrating how the readiness of different aspects of the ecosystem exist. Second is to conduct the research to enable the further urban air mobility maturity levels for high-scaled operations, including autonomy. And the third is developing this Book of Requirements construct that will be open source that allows everybody to basically understand what the readiness is of that ecosystem and build based on the requirements that are validated by simulation, flight test, demonstrations, and such.
Thank you, PK. We hear a lot. There's some misperceptions, I think, out there a bit about, let's call it on-demand urban air mobility. And I think I'm fairly safe in saying that in the near term, they're not flying to my house to pick me up and flying me straight to my destination. That there is one of the challenges, let's call it the first and the last mile, which is getting to where we're going to embark and getting to an interim destination, disembark, and get to our final destination. That from both a provider as well as those that are managing the cities and the land development, you talk about the challenges associated with identifying, placing, and integrating the ground-based operations into existing urban and suburban areas. So you all jump in on that how you like.
So the first and last mile has been one of the biggest challenges for urban transportation system that, like transit, public transportation. But I think technology have made it much easier now with what we call it the flexible fleet, the ability of flexible fleet to play into that first and last mile. So at Sandag, we obviously need to build the basic infrastructure. The private sector, where the innovation happened, has to be there saying, these are the urban mobility solutions. Government has to provide the policies and mechanism to make it happen. I believe today's technology offer a somewhat comprehensive solution for the first and last mile challenge. It is easy to get on a subway, but it's not as easy to get to the subway station and from the last station to your destination. That is what we're doing at San Diego. At Sandag, we're actually developing what we call the 5 big moves. The complete corridors, which every corridor has to be looked at as a complete system that provide choices. A second we call the transit leap, a subway, commuter rail, high-speed, fixed route system. A third, which is in a way a new concept in our world, and it's designed around the first and last mile, is called the mobility hubs. This is where things come together. This is where people change mode. This is where you change the transportation choices. And a fourth is the flexible fleet that's going to solve the first and last mile travel. So if you live in any part of San Diego County, and I guarantee you a trip on a different system that's shorter than the system you're doing right now, I think you might take it. But that's going to take a complete trip calculation, a first and last mile included. And finally, the operating system, the brains of the system. How do I get up-to-date, dynamically enough information to get that first and last mile? I believe we're going to overcome that challenge, whether it's urban, air, or ground, with the first and last mile. But we cannot overcome the challenge completely unless we design a system that integrates itself into a technological advancement that we see today, which is the next operating system, which is we at Sandag are pleased to join with companies like Deloitte and others who's willing to say, okay, here how we overcome with designing an operating system to overcome the first and last mile.
I would add in that I agree with a lot of what you just laid out. And at Uber, we've spent a lot of time investing in networks, and our contribution to this ecosystem is one of software and helping to really address that first and last mile challenge. And there are a number of challenges to solve. There's the challenge of how do you think about ensuring that you're on demand, being able to link someone with a ground vehicle to get them to one of these infrastructure nodes, the mobility hub you alluded to. There's the challenge of ensuring that you have very little latency in matching them with someone going to another place that is proximate to their final destination so that you can pull in that trip. There's a challenge of ensuring that you have another ground vehicle waiting to pick up a number of different passengers that have different end destinations that are in the same air vehicle as they arrive. And we find that the real value proposition here that makes this a really incredible business that's going to change society is the time savings. And so you have to do all this in a way that minimizes latency between the handoffs. And so at Uber, we have over 100 million active monthly platform consumers on our platform, and we think that gives us an opportunity to tap some really great software products to be able to help solve that part of the problem. We believe that there are some really great people in the ecosystem to invest in air vehicles and invest in infrastructure that we're excited to partner with that part of the puzzle. And so we think that's a way to be able to drive a system solution that we can help contribute to help solve what are some gnarly problems, but once solved, create a real unlock as it relates to not just delivering the time savings, but doing so at a price point that's accessible to folks.
Great, thank you.
So Robin, I'll add to that real quick. In the introductory comments, I failed to address our relationship with Uber, only because I didn't want to steal Wyatt's thunder here. But another constituent we have are moving people through our partnership with Uber Elevate. And we have a development in Frisco called Frisco Station, which we've built a vertiport, which now is a horizontal-based vertiport for this first phase of infrastructure investment to try to figure out how to accommodate this last mile opportunity. So when we look at the integration of the last mile as it is to people movement, there are so many questions that come to us as a real estate developer, and they're all related around infrastructure. So how do you invest in the right infrastructure at the right place to create a mobility house that's at the right place at the right time, fits the configuration of the local transportation system, and once you have that, where does it go? In the case of eVTOL, it has to be on a vertical platform. It needs to be somewhere off of the ground, so you begin to address the verticality of your adjacent real estate. Bringing to that, you have all sorts of modality connections you have to make with the on-demand transportation network that feeds an on-demand eVTOL. So that's just on demand. Now you talk about an air taxi service, which is a scheduled service, a little bit different and perhaps where Hassan would go. That infrastructure may be a little bit different than an on-demand model. Last mile is fairly easy from our standpoint because it's generally, at least in the real estate context, of a very large platform. You can solve that in your own real estate platform on public transportation systems today and under 400 foot in the aviation piece of it. So we think last mile goes first in both goods and people, limited. Once you get into air taxi and air on-demand mobility, it becomes much more complicated from our perspective.
Right. Scott, you need a place to land them eventually, take them off and land them. And I'm not sure to ask you as a service provider or as a manufacturer or both, but when you think about the infrastructure necessary to sustain the vehicles once they're ready, can you tell us a little about what you think we should be thinking about to ensure that those facilities are capable when we get there?
Sure. We're an interesting case study in a lot of senses. You know, a legacy OEM manufacturer. We changed our name from Bell Helicopter to Bell to represent the transformation of us becoming a technology company. So you'll see this year at CES that we not only brought a mock-up of our next vehicle, our all-electric Nexus, but we brought a mock-up of a smart city. And inside that smart city, our digital backbone called Eros is operating and flying little drones around. And it goes to this whole point of what is it that you have to do to answer all these challenges? Well, we know we can already bring a helicopter wherever you need it, but that's not the right solution for this next step in on-demand mobility. And so you have to have fleet management in the digital infrastructure that knows the state of charge in your vehicles, that knows the health of those vehicles at any given time, how far one has flown and how short another has flown. Do you have to then swap them? So in that digital space, you need a lot of data that becomes information that you can smartly act on. And that's what we're trying to do with Eros. We'll also do that with partners who already have systems like that. But then on the physical side, it comes into play of, well, you don't want a maintenance hub to be 25 miles away or 60 miles away that you have to start thinking about now moving those aircraft to that different location that's not dedicated to the core goal in a mobility hub, right, for example. So I think we have to have some maintenance capability at these mobility centers. I think that's the truest form of these real community vertiports. And we'd like to think that they can accommodate it. I know, Russell, you can build a building like that for sure.
Absolutely. And maintenance facility right on top for you.
That's right. So I guess my point is, it's about, again, those pieces that PK keeps talking about. A lot on the vehicle, but there's a digital infrastructure out there and a physical infrastructure that are going to play into all your maintenance decisions that you've referred to in the question. And you can't ignore any of those pieces, and that's why we're trying to show everybody what we're thinking about in both of those elements.
Jody,
yeah, I think that's such great conversation here, and I think one thing that's very clear is that we're all in a very steep learning curve across the entire front, and that does include the regulator, right? And I know we acknowledge in the FAA that the regulation and rulemaking process is painfully slow, but it is very deliberative and with safety always at the forefront. And I wanted just to highlight that the FAA is committed to looking at rulemaking, not in our old command and control form, but more of a performance-based rulemaking process, and with rules that can be more flexible and agile as technology advances and as we progress with this, because we've learned a lot. Now, NASA Grand Challenge is going to be just a phenomenal way for us to learn a lot, and we've got a lot of segregated activities throughout the U.S. The idea and our commitment is to reach that integrated system. So all of these efforts that we're talking about, the ultimate goal is to find that integrated system, and the FAA is committed to getting there by changing our approach to many things. So,
well, I'm going to draw on and use this as a segue to actually the next question I was going to ask you, Jody. You said integration. So from the FAA's perspective, the challenges we need to think about as we reached more of an advanced and scaled operations, how we integrate this into the air traffic management and operations here in the United States.
Well, in the opening, I certainly mentioned our pride is managing the safest, most complex, but safe and efficient airspace system in the world, and we have to be careful and cognizant not to overburden that system that's functioning now as we advance any new technology, whether it's UAM or commercial space or supersonic, or, you know, we could just go on and on at this point of all the new technologies. And so UAM is one piece of a much larger aviation advancement for the future. So that's one of the challenges. I think managing each other's expectations along the way. I think community involvement and engagement is going to be critical. Certainly in the FAA, we have learned many lessons from our performance-based navigation to our UAS and the integrated pilot program. We've learned a lot of lessons about engaging our communities early and often. Let them know that safety is in all of our minds, not just the FAA, but manufacturers and service providers, that safety is paramount and that their privacy and their security is of great consideration, and those challenges are being solved. And one of our favorites is, of course, noise. Whether it is real or perceived, we will have a noise component that we will have to address. There's no doubt about that. So those are some of the great challenges we see in the future.
So as we think about, I have this, visualization of how air traffic management works today. The pilot's on the, flies a flight plan, person in the tower gives them the clearance, they fly, they control them and bring them back down. In these tighter spaces with the volumes of potential vehicles from very small drones up to the cargo and passenger size, talk about will we have to think differently about how we control, manage, or allow the vehicles to operate in the space?
Absolutely. I mean, that's on the forefront of our minds, particularly in our air traffic organization, who may need to, look at a workforce of the future that has, maybe different skill sets. And, when UAM and some of the other technologies really started to surface, we realized this wasn't going to just touch one office in the FAA. It touches almost every one. I could probably make a case that it touches every single independent office in the FAA, from controlling traffic to technicians and infrastructure to our hiring plans and goals. So it's a big challenge, and it's taking not just the technical change in approach, but the executive leadership in the FAA to step back and really reimagine the future of the aviation system and our workforce and our role in that.
Right. Thank you. Yes.
So I was just to the earlier point, I will invite Scott and Wyatt to choose one of the 70 mobility hubs in San Diego to start building their infrastructure for their future fleet. But I think they both mentioned something important. If 70% of the world population is going to live in urban areas, and we have limited space in urban areas, we need to figure out how to use that space to the best advantage, knowing that there is technological advances. So mobility hubs and operation system. But something that we must discuss at one point, and that is how do we share data to inform that process? If I go to you and tell you, can you give me data about this? Company, same thing with Uber, same thing with Lyft. We need to start figuring out that none of this is going to work unless we have up-to-date information and in a dynamic way that gets to us. Because we at Sandag need to build the infrastructure, but we build it based on information. That information has to come somewhere. And I don't think we're there yet. I think to solve this physical limitations that we have and to solve the first and last mile, we need to get this data sharing, data information at its best level. Privacy is very important, no question. And everybody says, oh my God, everything we do at Sandag, people say, oh, what about my privacy? Well, if you have a cell phone today, you lost half of your privacy. If I Google me right now, I know more about me from Google than I knew myself. So we need to solve this problem, because this gets into how do you design an urban system that accommodate all the kind of things we're talking about.
I think that's a great point for me to jump on a little bit. If you visit us and go inside the walls at Bell, you'll hear us use a term called on-demand mobility, just generically to cover all of the categories of moving stuff. And we call stuff people, goods, and information or data.
Right.
And so we really want our system to provide on-demand mobility for all three of those pieces. And I agree with you that the information that we can get performing an air taxi mission or an unmanned logistics mission for a community like San Diego would be really valuable, not only to your citizens, but also valuable to our operations. So the feeling's mutual. I agree there's always difficulty in trying to establish what gets exchanged, and privacy is of course a big concern. But I think if you think about on-demand mobility as moving those three pieces around, you naturally answer questions about the data as well.
PK.
So thank you, Robin. So last 5 years, expanding on this topic of information integration, we have been working on something called Unmanned Aircraft System Traffic Management, or UTM. The idea of UTM is to scale these operations without overloading the air traffic control system as it exists today. We have been collaborating very actively with FAA and many industry members, including Uber here. The idea basically came about that we need to have so many drones in the sky, and how do we enable them without actually having to overload the air traffic control system. So we changed the paradigm to one from clearance-based operations to managed by exception. We made everything digital. All messages are digitally going back and forth. In order to have seamless information integration, we defined the application protocol interfaces, so all the operators connect into that, and we allowed the third-party services using the service-oriented architecture that allows you to get services from third parties and also connect to the FAA, so FAA can send in information or constraints related to airspace, yet it maintains the FAA's regulatory authority to ensure that these operations happen in a seamless manner. So that UTM we tested through 4 technical capability levels already, and that's shown quite a bit of promise. Last capability level was tested in the urban setting, and that's given us enough confidence to try that similar construct for urban air mobility operations at large. Of course, there are more things to be built on that. There are aircraft requirements need to be set differently for urban capable operations, as well as some arrival departure and demand capacity management, because these vehicles will operate from vertiport to vertiport. So there will be some more work to add on to the UTM construct, but we are well along the way of basically understanding how these operations could possibly occur. Now, as a government employee, I will make a public service announcement here. We have 4 NASA centers, NASA Ames, NASA Armstrong, 2 in California, NASA Langley, which is in Virginia, and then NASA Glenn, which is in Cleveland, Ohio. They're all working together along with our headquarters, which provides us the strategy to enable these operations. So if you get a chance, please talk to the NASA employees. Some of them are already in the audience, and go visit their websites and see the capabilities, and maybe perhaps you can leverage these capabilities for testing as well as research and simulations and such. One of the areas that we haven't talked quite yet, which I would like to put forward, is it is going to be very critical to make sure that we have supply chain management and manufacturing capabilities that will scale these operations to support the scaling that's expected. If we can manufacture only 50 a month, as it happens today for large OEMs, that will not scale these operations. So we really need a different level of supply chain management, as well as scaled manufacturing capabilities for everything. Motors, actuators, composite, you name it, everything that's going to go into those parts. And also third-party aftermarket possibilities, because things may break down, and if they do, how do you maintain those? Just like the car network, you have the maintenance repair stations and such. We will need a significant amount of supply chain management and manufacturing capabilities. To that, NASA has taken leadership, and we are going to host a workshop to discuss this. That information I passed around some of the papers, but you can also do search on NASA's workshop, or if you find me on LinkedIn, I will send you that information, or find on the NASA website at nari.arc.nasa.gov, and Aero Supply Chain, you will see the workshop information. But it's critical that we break all the barriers and figure out different ways that we need to make sure that this type of operations continue to grow and sustain.
We signed a Space Act agreement with NASA a few years ago at Uber, and it was really, building on what PK is saying, an important step for a lot of testing of airspace management services, and they've done great work tying back to this topic. That's one of the reasons why air mobility will be able to move autonomous. It's because of very, very thoughtful procedures that are predefined in a network system that is between existing nodes that we have lots of clarity about. It's not people choosing their own adventure in the airspace. And it's because of that real systems approach that you can be able to get to scale. And we can get to numbers that really enable us to move large quantities of people on demand because of that transition to autonomy and because of those predefined routes that we can fly in the airspace. And so credit to NASA for leadership there. And credit too for the ecosystem. And FAA has been at the forefront of that for leaning into it as well.
So numbers, what are we talking about in numbers? If we just say the United States, by 2035, what you may in your hip pocket, what's sort of the numbers? And I have a follow-on then, Scott, is a little bit of what we talked about before, which is the manufacturing at automotive scale rather than handcrafted helicopter scale. I'm assuming there's a difference in those, but the numbers and then how we think about changing our industries to do that.
And I'll defer to the experts at Bell to talk about their processes. Global civilian aircraft market in rotorcraft is around 1,000 units a year in terms of a production rate for non-military purposes, civilian purposes. At Uber, we see the opportunity here is to scale 20 times that over the time frame that you're alluding to. That's only possible if you do the things that PK alluded to around moving to automotive-like production rates and having really thought through the opportunities that composite manufacturing will unlock and the scale it can adopt. We're excited by a lot of the investments that leaders in the automotive space are making. There'll be some announcements this week at CES to watch out for. And we're excited about some of the legacy makers like Bell are doing to think about how do they make that pivot. And I think that's going to be really important for getting to that type of scale.
Yeah. Scott, how do you think about your change in manufacturing?
Well, Wyatt just did the hard part for me. All I need for what I have to do is hear my customers say 20x, and I'll just categorize that as a big change. And I'm always thrilled when there's information out there because that's what drives our decisions and that's what drives the market. A lot of times people are afraid of these future markets because you don't have a precedence to look back on. And Uber has been fearless in that. And I think everyone on this panel has been fearless in looking forward to a space that may be unfamiliar but holds great hope. So from a manufacturing standpoint, if you just think about those scales, we love when there's hundreds of units per year built. That's a moment to crack the champagne, as we say. But if it moves into thousands per year, we have to change our manufacturing techniques. We do have automation today in our factories, but there is this sense that helicopters and tilt rotors are handcrafted in a lot of ways, and that's not okay for larger scales. And I think people have to be smart about where they partner there too. We're great at the manufacturing scale for the product that we do every day. There are others that do massive numbers like the automobile folks. And that's not the kind of numbers we're quite talking about. It's somewhere in between. So maybe there are opportunities to bring aerospace and automotive together, learn from each other there in terms of manufacturing scale, mechatronics, and thinking about the manufacturing floor in a different way, maybe where tools can do multiple pieces of the work stream rather than just that big volume piece of I'm going to stamp a rivet a million times today. Maybe there are cellular manufacturing techniques where single tool stations or single machine stations can do multiple tasks for the line. But it's transformational to say the least, and it's something that we're thinking about a lot. I'm focused on the flight technology part of innovation. I have a partner in crime named Glenn Isabel who looks at rapid prototyping and manufacturing innovation. Our two teams are co-located, and so let that be kind of Bell's take on how important it is to have these two pieces at the forefront of your mind at all times.
Right. So we started the conversation 15 minutes ago talking about consumers, and I'm going to try to end and transition back a little bit to the consumer side of this. Jody, you mentioned noise. That's been something that's been critical of the helicopter market for a while, and I'm told, while I'm not an expert, that it's prevented some deployments of helicopter as a mobility tool in and around urban areas. As we think about how should we think about noise? as those representing constituents and then those that are providing or building, what's being done to change noise, or how does that affect eVTOL aircraft? How do you guys think about noise? Sorry. Jody?
Oh, yeah, I did. I thought, sorry about that. So what we've learned early on is to start the conversation with communities early. And when they see something different, different flight paths or different, in this case, vehicles, or it's about engaging them before the activity really starts, and holding community forums and talking to them about the benefits and some of the characteristics, particularly of aircraft, that that they need to understand. They're concerned about safety, and sometimes noise, we go out and measure it, and there's a valid concern, and sometimes it's a visual thing, right? Because we've seen a different path, and I'm talking about manned aircraft right now, but now you've got aircraft on a very distinct pattern that is very precise, and so those homes under that, were alarmed. There wasn't really an increase; it was just more concentrated. So I think we apply those rules into this environment and UAS and all of the different new entrants, and realize that. The community, whether they are aviators or not, need to be involved in this process.
Yeah, one of the things NASA is famous for is noise models and the noise research that we have done for decades to understand the different characteristics of the aircraft design, propellers and such, and its impact on the noise. And then we also look at what would it take if the density increases, how the noise footprint cascades and such. So we have a number of modeling efforts and analysis efforts going on inside NASA to understand the noise characteristics as well.
One of PK's former colleagues at NASA, a gentleman named Mark Moore, who's really a leader in this sector for the world, joined our team 3 years ago, which is really a critical moment for us in really committing behind the Elevate initiative, and it brought a real focus on noise, and that's become the core of how we thought about what would be an unlock for communities. Our thinking is that there's the absolute value of noise, and then there's how it feels. And so being really thoughtful about what is the physiological impact of noise, and then doing some early work, which we've been open about, around getting some baseline noise levels. So you think about, as you introduce the technology, what does that mean in terms of how people experience the noise, and then doing the community engagement work really well. So your point about that was so well made. If I could brag on Russell, the work that they lead as a convener in North Texas at Hillwood is essential for being able to create, I think, a case study for how to do this well, and engaging with local elected and appointed officials, with civic groups, and it's been a really valuable part of our partnership with them. I think some of the work that's happening in San Diego, we've been a participant in the FAA's integration pilot program there, and that's been a similar experience around being thoughtful about that, and it will be true everywhere else as well. And so I think that noise tied to community engagement is a really important thing to get right, and it relies on being able to bring the people that are building the technology too, to talk about the innovations that they're driving around how to lower that perceived feeling of noise such that this can be something that's widely adopted.
I think you're right, because if it's not addressed, there's nothing that will stop us dead in our tracks than an upset community.
Yeah, so I'll add to that. So if you sit here and you think about equipment manufacturers, digital infrastructure, the physical infrastructure, you have groups that are all working in silos, and what we're talking about now is beginning to connect these silos and educate our consumer and our public. And that's happening in ways that we've never seen in terms of mobility education. So I'll give you a couple of examples. So how do you take a noise modeling program here and push it out to your constituents in the community neighborhood? Very easy. You go model around that and you walk out to the community. They say, great, the noise is wonderful. Now tell me about, next question is, how close is it going to fly to my rooftop? Is it flying a highway system, or is it flying diagonally across? So the united front of all participants up here that are talking to one another about the questions that our constituents, our public's going to have, and having answers in a unified and consistent manner that's backed by logic helps move these initiatives at light speed.
Absolutely, and I just want to highlight too, the very first place to start is with the community's elected leadership, and engage those folks that know their community so well to help be the message of what we're trying to do to educate a community when we go in.
If I might be so bold, let's start consumer acceptance, customer acceptance, community acceptance right here in this room. I'll take you as the start of the community. People who are used to adapting new technology, that's what CES is all about. The vehicles that we are designing have a radically different noise profile than traditional helicopters, traditional VTOL aircraft. We already know it. We run our ducts today at full scale, full power, and the noise is way lower than anything you've ever expected or experienced in traditional VTOL. So take that message from me and Bell, and I think everyone here would validate that as well, and bring it out to your communities today. Start telling people that the time savings that Wyatt is talking about is going to change your life, and the cost of the vehicle, the noise it creates, and the integration in the community is going to be great as well. We're going to be the leaders. This whole room here is going to be leaders in advancing this technology to our communities that aren't used to this kind of tech in their world.
Yeah, well, so, you know, if I were to survey, say, the coastal communities in my county, and I would say, do you believe we need to reduce greenhouse gas emissions? I'm almost certain 90% will say yes. The next question, would you mind if I put a couple of trains that will maybe blow the horn a couple of times a day? I think that number probably will be, oh yeah, I wouldn't mind it. Here's what's working for us, and I agree with Wyatt. We do need, with Scott, we do need to start early on, be upfront about it, show the best modeling and data about it. But we also need to educate the community about the pros and cons. If I could reduce your travel time by 1 hour and inconvenience you with little noise that's not, in terms of health, is not bad for you, maybe that education has to start early on. But I will tell you this, there will be no scenario where we're going to make progress and do the future mobility without accepting some standard change. And that is where the early education for the community comes in. You know, I remember in 1995, I was in Los Angeles. And I remember when Uber started coming online. And I remember when city council members were running around to start writing regulation to regulate this, regulate that, regulate. And if it left up to government, probably you won't see. So the point is here, start early on, put the issues on the table. Some inconveniences will happen, but the great progress has a price, but that progress will make everybody's life better, will reduce greenhouse gas emission, will reduce travel time, will make our urban regions sustainable and livable. And that's, I think, what we need to start doing, back to the comment about start early with the communities.
So to add to that, we are doing two things. One is we are working with Deloitte to do comprehensive concept of operations to see how these operations will work, how will we scale them, what are the issues. And the second is we're doing modeling and simulation environment, building modeling simulation environment that takes into account the operations, the location of different vertipads, the noise models, the evacuation strategies in case you need to evacuate, the zoning requirements, the fire codes, all of those things that are actually interesting to consider when you decide where to put the vertipads, how close the pads and vertiports should be. These kind of decisions are hard to do just sitting around a table and by drawing charts, but we need some modeling simulation environment, and we're building that so that we can take into account the demands that different operators like Uber bring in, and taking the models that Bell has about their aircraft and the locations, the alliance, and their specific use cases and such, so we can actually allow the operators as well as the localities to make decisions about how to enable these operations along with the FAA's regulatory environment. So these kind of efforts going on to try to help communities to understand what is the best way to make these decisions to enable these operations.
Robin, let me add to that. So how do we do that? So we have a regulatory world, we have original equipment manufacturers, local regulatory. So how do you do that? How do you accelerate this curve which bends the cost curve down? And that makes it affordable for us to scale and deliver service. Well, you have to have a testing area in a complicated airspace from, let's say, G to E, of which you can move through and begin to test this technology under the safety guidelines that FAA and NASA have set up. You put your traffic management system in there, and you begin to stress that. That's what this panel up here, in another way, is working on at Alliance, Texas, and that is building an unmanned aircraft testing zone that allows us to stress this very quickly, both from just a logistics movement of goods, and then ultimately people around answering these questions of safety. What's the equipment? How are you going to manufacture it? What's the scalability of it? And ultimately to the question of when can you fully deploy autonomous vehicles. So that piece of it right here is, I think, is the most important takeaway for me, is that you have folks interested in how do you stress the system quickly, and in what environments we could get those answers and get about deploying.
Outstanding. Well, thank you all.
Thank
Jody,
you.
Wyatt, Scott, Hassam, Russell, and PK, thank you very much for coming in and spending your time with us today. That's all we have. And can you join me in thanking them for their time?